video this. Okay, so when you have a fraction, we have something that looks like a box or a circle or whatever, and the total number of pieces is going to be your denominator. So we have 1, 2, 3, 4, 5, 6. So we already know 6 is our denominator. If we fill in 1, this would be 1/6. If we fill in 2, this would be 2/6. 3 would be 3/6. 4 would be 4/6. So it depends on how many is filled in. So suppose we kept it at 3/6. So this is the part that is filled in out of 6. An equivalent fraction would be the same size box, but instead of having 6 boxes, maybe we have 12. So I'm going to make 6, and then I'm going to cut them in half. Now we have a 12th. And then I'm going to fill in the same. See how this is the same? And then I'm going to count the number of boxes. 1, 2, 3, 4, 5, 6. So 6/12 would be the same as 3/6. Does that make sense to you so far?
Mm-hmm.
We just cut that same square into a different number of pieces. And then if I had another square and it was just divided into 2, and I colored this in, that would be 1 box shaded in out of 2. These are all equivalent fractions. And then we can even do more. So we could take our original 6, and I can cut them now into more pieces. Okay, so now we have 24 pieces, and I've got to get half of it filled in. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all of these are the same fraction, but with just different number of pieces cut into my shape. Does that make sense to you?
Mm-hmm.
Okay, so I want you to come up with a different denominator, and I want you to do 3 of them. So you're going to make 3 squares, try to make them the same exact shape, and cut the first one into whatever number of pieces you want.
Okay.
How many did you cut them into?
First one?
Yeah.
Um, 21.
Okay. So did you do 7 across and 3, 7 down and 3 across?
Mm-hmm.
All right. And then how many pieces did you fill in?
Mm. 12.
Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you're basically going to take this same amount and you're going to know that whatever you cut the box into, it's going to be this filled in. So if you cut it into anything that is divisible by 21. So you can cut it into sevenths, you can cut it into 14ths, you can cut it into 28ths, but it has to be divisible by 21. It has to be able to be a factor of 21. So if you did 7, it would be 1, 2, 3, 4, 5, 6. 1, 2, 3. It's hard because we're not like computers. 1, 2, 3, 4, 5, 6, 7. So we would color this whole thing in. We would color, if we did more, we would color this. Does that make sense to you?
Think so?
Okay. So basically you find a fraction and then you cut all of those in. And the algorithm way to find it out is to do the common denominator. So if we had 3/6, if you want to find something you could cut into, you could multiply it by 2, you could multiply it by 3, you could multiply it by 4, and all of those would give you equivalent fractions. So this would be what? 3 times 2 is 6, and 6 times 2 is 12. That's how you multiply fractions. You just go all the way across. 3 times 3 is 9, and 6 times 3 is 18. 3 times 4 is 12. 6 times 4 is 24. So all of these are equivalent fractions. And we could make our box. So I'm just going to make one great big box, and I'm going to divide it into 1 box, 2 boxes, 3 boxes. So this one is going to be 1 box all by itself. This one's going to be the second box, and this one's going to be the third. In this box, I would have 12 pieces, and I would cut it into 6. In this box, I would have 18 pieces, and I would cut it into 9, or shade 9. And then this one, I would have 24, and I would shade 12. So just for easy sake, we know 6/12 is a half, right?
Mm-hmm.
So all of these are going to be a half. And then we need to figure out how we would cut this into halves. So we know half of 12 is 6. So our first half is going to be cut into 6. 1, 2, 3, 4, 5, 6. And then the other half's going to be cut into 1, 2, 3, 4, 5, 6. This one's going to be cut into 18, so we know this piece has to be 9, right?
Mm-hmm.
And then this one's also going to be cut into 9. And then this one's going to be cut into 12s. And then this one would be cut into 12s. I don't know if this is 12, but okay. Does that make sense to you a little better now?
The multiplying fractions?
Yeah.
Yeah. So it's kind of like you multiply the bottom one and the top one, so it's kind of like multiplying. It's kind of like basic multiplying.
Yeah. So let's do 1/4 times 2 over 2. What would that be?
2 over 8?
Yeah. And this number does not have to be the same when we're multiplying regular fractions. It just has to be the same when we're finding equivalent fractions. But if I just said, we're not finding equivalent fractions anymore, we're just going to multiply fractions, then I could do 1/4 times 2/3. And the steps would be the same. I would multiply the numerators together and I would multiply the denominators together. But when we're trying to find equivalent fractions, we need the numerator and the denominator to stay the same. That's the only time we need it to stay the same. Does that make sense to you?
Mm-hmm.
Okay. Okay. So visually adding fractions, how did you go about doing that? What did you do?
So draw two squares, and make sure they're at least the same length. It doesn't matter how high, how big they are. Just they have to be at least the same length.
Yeah.
And then if you are adding 3/5 plus 5/9. I mean 5/10. So you'd color in the things that you need to put in.
Like this?
Yeah.
Uh-huh.
And then as you just for the 5, kind of pretend to draw lines, so it's 10 2, and then just add them together because it's you changed it. It's you changed them so they're both 10.
Yeah. So you could cut this in half, and now this would turn into 6/10. And then you would have 1, 2, 3, 4, 5. So this would stay 5/10, and then you could count the number of tenths you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11/10.
Mm-hmm.
Okay, so it seems like you understand that.
Mm-hmm.
All right. So let's find out. We have an improper fraction here. And what an improper fraction means is that we have a numerator that is bigger than the denominator. We cannot have that. So we need to do something to fix it. Basically, what you're going to be doing is you're going to be taking a shape and you're going to make it into 10 pieces. So 1, 2, 3, 5 on this side, and then we have to have 5 on this side. Okay, so we have our denominator. So you're going to fill in a shape with the number of squares or parts or pieces for the denominator. And then we're going to start coloring in oh, I've run out of squares. This is 10/10, and I need to model 11/10. So what do you think I need to do if I've run out of space?
Make another one.
Yeah. So I have to make a whole nother square, and I have to split it into 10 pieces. And then how many of those would I fill in for my second box?
1.
Yeah. So A mixed number means that you have one whole and then some other, or 2 holes, or 5 holes, or 7 holes, or whatever. Plus, you had to start a whole nother box. So we have one whole, and then we have 1/10 of another box filled in. So that's called 1 and 1/10. And we write it just like this. Pretty cool, huh? Not too cool?
It's pretty cool.
Okay. Let's try a harder one. So if we had 23/5, how would I model that? How many would I split this box into?
5.
Yeah, so if I had 5 squares here, that would give me 5, right? So this is 5 out of 5. What would I have to add to this? Would I need to add another box?
Yeah, add more boxes.
Another one, right?
Mhm.
And then what would I have to do?
Make more of them because we still don't have enough.
Exactly. So how many boxes do you think I might need? I have 5. I have 10. This would give me 15.
You need 2 more boxes, but only fill one of them up with 3 though.
Yep. So we have 5, 10, 15, 20, and then you said the last box I just fill with 3. So 1, 2, 3. So I have 1, 2, 3, 4 holes, and then 3/5 of my last box. So that's a mixed number. So now we can talk about subtracting. So if I wanted to subtract 1 and 1/5 off of here, what I would do is get rid of one whole. Oh, let me get a better marker. I would get rid of one whole entire box. And then I would get rid of 1/5 of another box. So then that would give me 1, 2, 3 whole boxes, and then 2/5 of my other box. Does that kind of make sense now?
Yeah.
Okay, so I'm going to stop the video so it doesn't get super long.